All right, let's look at the ODE Practice Exam 4, Problem 19. All right, so we want to show that all these following functions are of exponential order. All right, so let's do that. All right, so let's look at part A. So we take the absolute value of t. All right, we know that this is going to be less than or equal to e to the t. All right. So we can take t to be, so therefore, all right, so maybe this is starting from 0. So we can take t to be, capital T to be 0, and let's see, c to be 1, right, because it's, the number in front of t is 1, and then also m is going to be 1, right? All right, sine is a little bit easier because here, sine of t, biggest is sine could be is 1, right? But e to the t is greater than or equal to 1 for t is greater than or equal to 0. So therefore, for this one, we can take t to be, again, 0, right? And the c to be 1. And the m to be 1 as well. All right, so let's do this one. All right, so 5t squared, all right, so we don't really need the absolute value because this is never negative. All right, so we need probably 5 here, all right? Then t squared is always smaller than e to the t, starting from t is greater than or equal to 0. So therefore, we have t equals 0. And the c equals 1, and the capital M equals 5, all right? And the d, all right, absolute value of negative 3 e to the 5t, all right, so this is going to be less than or equal to 3 e to the 5t. We just took away the negative sign, right? So, this is t is greater than 0, so therefore, we can set capital T to be 0. All right, and the c to be 5, and then m to be 3. All right, then last one. So we have a little bit of shifting here. U t minus 1 hyperbolic cosine of t minus 1. All right, so this can be bounded by, all right, I can throw away u of t minus 1 because it's either 0 or 1, right? So it's going to be bounded by, of course, the hyperbolic cosine of t minus 1. All right, and go to the definition of hyperbolic cosine is e to the t minus 1 plus e to the negative t minus 1 and over 2, right? All right, then I'm going to replace with something larger, right? Exponential function is a increasing function. If you replace this guy by larger value, for example, e to the t, right, it's going to get larger, right? Then plus, right? So this is a e to the negative t minus 1. I'm going to replace by e to the t. Then I'm going to say t is greater than or equal to 1, so that this expression is always e to the negative power, right, or e to the 0, right, then over 2, which is equal to e to the t. All right, so therefore, we can set capital T to be, say, 1, right, so that's 1, and the c to be, that's the number in front of t, so 1. And we can have m to be 1 as well. All right, so therefore, all these guys are eventually of exponential order. All right, that's it. I hope that this was clear.